In this lesson, we're going to explore parallel lines. There's a little investigation that I would like you to go through on GeoGebra.org. So you're going to go to that website, and when you go there, it should look like this. The instructions say to download, and you can do that, but you don't have to. You can go to the apps here in the middle, and then you'll get a window that looks like this. Okay. We're going to do geometry. So you should get a geometry. Oops, it's on calculator geometry. And you should get something that looks like this. Now before we start the investigation, we'll go back to the notes here for a moment. And we're looking at some definitions here. So the first definition says transversal. A transversal is a line that intersects two or more other lines at distinct points. So this here, this red line here, that's your transversal. Okay, you've got two other lines here, and I know they're lines, they've got arrows at either end going on forever. The transversal is a line as well going on forever, but it's intersecting the other 2 points. Okay, so here it says, where do we see parallel lines in our everyday lives? So you can think about things. So what is a parallel line? Parallel lines, there's a pair of lines or more, so you have to have 2 or more lines that you're comparing to one another. And I could see here those 2 blue lines are not parallel, because if I extended those lines on forever and ever and ever, I'm not using a ruler here, but eventually they will meet and they will cross. So that means they're not parallel. So I can think of things like railroad tracks or window panes, like on the edges of the window panes, where if they go on forever and ever, if we extended those lines, they'll never cross, and that's by design. We don't want those railroad lines to cross. We don't want those borders around our window to cross, because that's what's holding things in place, right? Holding either the glass in place or holding our train wheels in place. So what are some potential problems when lines are not parallel? We talked about that. And what could you do to determine if 2 lines are parallel? Well, let's have a look at this investigation to see how that can help us. Now, you could do this independently, or you can do it along with me. The GeoGebra website works on lots of different platforms, so whatever you choose to use there. So it says click on view and unselect the axes. We already have no axes. Now it says complete the following steps to draw 2 parallel lines and transversals to these lines. And by having that, we can actually move things around and see what's going on. So it says complete the following steps, construct the line segment AB. So going back here, if you go into the menu here, we want to construct a line, and we're going to construct a tibby. Now, I don't have a line segment here, so I'm going to hit undo, and instead of selecting line, go to segment. And that's a very small segment. Extend that out. And now I've got line AB. And now if you want to right click on there, you should be able to show label, and you'll get those labels on there as A and B. Oops. There we go. Now it says construct a point X that's not on the line. So just a point here that's not on the line. To change the letter of a point, right click the point and select rename. So we go ahead and do that. Rename, and we want that to be X. Okay. There we go. Construct a line that passes through X and then that's parallel to AB. So if we go up here, there's this menu here, and click on parallel line, and you'll see at the bottom it says parallel line, select point and the parallel line. So if I select the point and I select the line that I want to be parallel, it'll create a parallel line. Now it says constructs points Y and Z on this new line as shown. So we'll just create new points, select a point on the line and another point on the line, and we'll rename them the same as our drawing there. So we're going to show label, and then we're going to rename it. We want this one to be Y. We're going to slide that here, and then do this one. I guess I could rename it right away instead of labeling it first, and have Z. Now if I go back to my notes here, you can see that's what I'm doing down here, right? I'm just following along. So that's X, Y, and Z, and A, C, and B. I don't have C on there yet, but I guess we can do that next. So let's go back there, and I'll create C. And just go show label, and there, that's our C. Oh, that was the next instructions. Anyways, it says construct a point C between A and B. Now it says construct a line Y to C. So let's do that. So I'll get a line here. Line from Y to C. There we go. Now construct points, 2 points P and Q on the line YC as shown. I'll put one up here, one down here, and label those accordingly. That one's P. And that one's Q. Okay, now mine's going a different way. No problem. If you want to grab that and move things around a little bit, you can do that. So now it looks more like what we had going on there. Now it says measure all the angles that are formed by the parallel lines in the transversal and label them on the diagram above. Okay, so there's this menu here where you measure, and then we want to measure the angle. And now you're going to click the 3 points that you're trying to measure. And that's given in there. If I want to measure this angle here, if you look at those two, they're the exact same size. Now, as you measure more and more angles, they're going to start to overlap, and it's going to be a little bit tricky to see. So you might want to label those ones on your diagram first, and then go ahead and label the other ones, and that's what I'm going to do here. Now, if you did this and you got a little bit of a different angle than me, that's perfect. You don't have to write the exact same angle measured down that I did, whatever you got in your investigation, as long as you're recognizing the patterns. So here I have this angle, and that's 116.35 degrees. It's important to put your angle measure in there. And I recognize that this is the same angle, 116.35 degrees. Now if I hit undo on both of those, they're going to clear out just so I can see my other angles. So now I'm going to measure the angles again. Now I'm going Z, Y, P. And the reason for that, if I go the other way, if I go P, Y, Z, it gives me the other angle, okay? Because they all add up to 360, and I'm not wanting that angle in there. So you're always going clockwise. So Z, Y, P, just with GeoGebra. That's 63.65. And this is also 63.65. So let's label that on our diagram. So that was this angle in here, 63.65 degrees. Okay, let's get the other angles. Measure C, Y, Z. It's 116.35. Q, C, B, 116.35. So that's interesting because we've seen those before as well. So that's here. Okay, and you can maybe also anticipate what these last angles are going to be. And let's just measure them just to be sure. And that would be X, Y, C. Yep, 63.65. A, C, Q, 63.65. So let's go ahead and put those on there. Okay, so those are all the angles measured. So when we have two parallel lines, we can see that opposite angles are equal to each other. We can also see that corresponding angles, so when they're sitting in the same spot on the other angle, right, we can actually see those are also the same. We're going to call those corresponding. We can also see, I don't know if you noticed, if you add those two angles, they across are making a straight line, right? This is our straight line here. So across this angle adds up to 180 degrees. 116.35 plus 63.65, that would give you 180 degrees. If you go this way along the line, same idea. These add up to 180 degrees. These add up to 180 degrees. So there's a lot of patterns that are going on there. You can see, right? These are corresponding angles. Our exterior alternate angles are equal. Those are exterior alternate. These are exterior alternate. Lots of words, lots of language that's going to come up. And you're going to be using all of these words and all of this language in order to explain when you can see angles are the same. Okay, so parallel lines, we've got these 8 angles and they all get special names. These are consecutive interior angles. They add up to 180 degrees as well. So let's go down here and see how we named and labeled all these. I think I've labeled them all for you, but seeing them all mixed up together, it gets overwhelming and it's hard sometimes to distinguish. And that's the practice. The more you practice, the more you use the language, the better you'll get at it. So if we look down here to start, interior angles. So those are these 4 on the inside. Those 4 on the inside, it says any angles formed by a transversal. Remember, our transversal is this line. So those 4 angles were formed by our transversal and 2 parallel lines that lie inside the parallel lines. A, B, C, and D are called interior angles. Our exterior angles are out here. Any angles formed by a transversal and 2 parallel lines that lie outside. And then corresponding angles are sitting in the same spot. So one interior angle and one exterior angle are on non-adjacent and on the same side of the transversal. So I always like to think of, if I were to actually, I'm going to draw over this, if I were to take this line and this piece and lift it up and put it over this line and this piece, this angle should be sitting in the exact same spot. So they're corresponding or matching. Okay. Let's take a look at the next page here. It says use the relationships you observed to predict the measurement of as many angles in A to G in this diagram as you can and explain each of your predictions. Okay, so knowing what we know, this is a good time to hit pause on the video and actually try it out on your own because I think you've got this. So does it matter where you start from? No. Does it matter that some of your explanations might be different than mine? Yes, that's fine, because depending on if you actually did this in order or not, which you don't have to, will determine what your explanation is, and I'll follow that through. So if I start with A, angle A here, well, I'm recognizing that A and 140, those are sitting along a straight line, and we know the angles along a straight line have to add up to 180 degrees. So I can see that angle A is going to be 40 degrees. 180 degrees minus 140 degrees is 40 degrees. That's how I got that value. We call these angles supplementary angles. Angles that add up to 180 degrees. Okay? Now, if we look at B, and when you do these, just as a reminder, label those angles on your diagram so that you can keep track. I also recognize that when I was doing this, opposite angles were equal. Did you recognize that? Did you remember seeing that? Let's go back and have a look. So if I were to look at this one, and the opposite angle, the one directly across from it, those were equal to one another. Okay, and you could do that you could do that the other way too. Okay, so if I erase those and I look at this one and this one, those are opposite, right? They're directly across from each other. Those were equal as well. So if you go back to the page we were just working on, if I look at 140 and B, those are opposite from one another, and I could say that's 140 degrees for that reason. Or you can say that A and B are along a straight line and they're supplementary angles, so that's 180 degrees, which would make B 140 degrees. So whatever your reasoning in is, no problem. I'm going to put that it's 140 degrees because opposite angles are congruent. So the word congruent we use often when we're using angles because it's just saying that the angles are equal or have the same value. Now angle C is going to be 40 degrees. Lots of different reasoning you can use. You can say that, well, this forms a circle. They all should add up to 360 degrees. So if this is 40, this is 140. C has to be 40 as well. You can see that A and C are opposite angles, which is what I'm going to say, and opposite angles are congruent. Or you can say that these two are supplementary or these two are supplementary. So again, there's lots of different paths here, but the easiest for me to see was just that A and C are opposite to one another and they're going to be congruent. So C is 40 degrees because angle A is equal to angle C. And that's because opposite angles are congruent. Alright, so I'm done those top ones. Just label those. Now they're starting to ask about D. Now angle D is equal to angle A, which is 40 degrees. Why is that? Well, angle A and angle D are corresponding angles, and corresponding angles are congruent. This angle A is sitting in the same spot that angle D is sitting in those bottom four angles. It's a matching angle, so we consider it a corresponding angle. Now angle E and angle D are both sitting along a straight line, and I can see that they are supplementary. So angle E is going to be 140 degrees. How do I know? Well, angle E is equal to 180 degrees minus angle D, which was 40 degrees. That's where I got the 140 degrees, because it's supplementary. Angle E and angle D. You might also have said that angle E and angle B are corresponding angles, which is also true. Now angle F and angle E are opposite angles, so they're congruent. So I would say that angle F is 140 degrees. Oops, not corresponding. Opposite angles. Are congruent. And finally angle G. And angle G, so I'm going to label these other ones. So angle D was 40 degrees, angle E is 140 degrees, and angle E and angle F are opposite, so that's also 140 degrees, and you're left with G. And angle G is equal to angle D for the same reason. They're opposite angles, which are congruent. So we've figured out all 8 angles, and this is all based on the investigation we did above. And really, you can use the same property each time. I talked about supplementary angles, angles along a straight line adding up to 180. I talked about opposite angles, where when angles are across from one another, like 40 here for A and C, that they are equal. But in reality, all we really need to know about were the corresponding angles. If those angles are sitting in the same spot, right? 40 sitting in the same spot, 140 sitting in the same spot as F, so those were equal to one another, right? And you can use that over and over and over again. So let's take a look at the next page here. It says when a transversal intersects a pair of parallel lines, the corresponding angles that are formed by each parallel line and the transversal are equal. We could have used that over and over and over again. We did need the supplementary angles to get the ones on the other side, but other than that, you didn't need to use the opposite angles or equal. It's an easy one. You can use it for sure, but as long as you had the supplementary angles on the corresponding angles, you could figure out all 8 angles pretty quickly. When a transversal intersects a pair of lines, creating equal corresponding angles, the pair of lines is parallel. So forwards and backwards, you can also see if I gave you those 2 angles, you can draw a conclusion that those 2 lines are going to be parallel. And that's these markings, just so that you're aware. Those markings are telling us that those lines are parallel. Now, if the transversal intersects a pair of non-parallel lines, you cannot make the same conclusion. The corresponding angles are not equal. There are also other relationships among the measures of 8 angles formed when a transversal intersects 2 parallel lines, and we're going to go into that further in our next lesson. Thanks for joining me today.